we're going to do another example of combustion of a hydrocarbon. This time we're going to work with, this is called methane. We're going to burn methane in oxygen, and we're going to get carbon dioxide and water. Now, as we can see, this is not balanced, right? Because we don't have the right numbers of stuff over here. For instance, we have 4 hydrogens here, but on this side we only have 2 hydrogens. Likewise, we have too many oxygens over here and not enough oxygens over here. So, as it stands right now, we have this black one right here is carbon, and these white ones are hydrogens. There's 4 of them, right? That's a molecule of methane. This is a molecule of oxygen. It's O2. There's the red ones are oxygens. There's 2 of them, O2. And then it's supposed to go to CO2 and H2O, but obviously we're deficient. We don't have enough oxygens. Because if you had, there's 2 oxygens here, but we'd need another one to come from somewhere. So we're going to default and do our method of balancing hydrocarbon equations. And that we start with carbons. So let's see, how many carbons do I have on this side? Well, I have 1. How many do I have on this side? Again, we have 1. So we're good with the carbons. Okay, now we're going to move on to hydrogens. How many hydrogens do I have over here? Well, a total of 4, right? Now, how many over here? Well, okay, none there, but we have 2 here. So we're deficient, right? And remember, we can't change the formula because then it would no longer be water. If I were to write H4 here, well, now we don't have H2O. We have H4O, and you don't want to drink that. That's bad. So we have to throw a coefficient out here, and if we put 2 here, then that would give us a total of 2 molecules of H2O, and altogether that would give us 4 hydrogens. So now we're balanced with hydrogens. Now we move on to oxygens. We saved oxygens for last because over here it's alone, and it's really easy to just throw a coefficient in front of there. So let's see. Here, number of oxygens, we have 2, and then another 2 from here, because if we have 2 water molecules, the total number of oxygens we have is 2. So we have a total of 4. So now we only have 2 oxygens over here. So how do we get from 2 to 4 oxygens? Well, we could just multiply by 2. And this may seem like a really simple example, and it is really, but this is something I really want to illustrate here. Is that, yeah, we're throwing around a lot of numbers, and yeah, that's all well and good, but what does that mean exactly? Well, this means that the only way to get this out of this is if you have the right numbers of everything. For instance, if you had like, one O2 and 900 of these, you're not going to get the right ratio here. So for this to happen, you have to have 1 molecule of methane, here, the CH4, and 2 molecules of O2. And for every bit of that you have, you should get 1 molecule of CO2 and 2 molecules of H2O. And let's see if that works. So I'm going to take here we go, we have 2 O2 molecules. I'm going to take one of them and go ahead and build these H2Os. So I'm going to take my methane and take off the hydrogens, all 4 of them. Okay. Here's my O2. Drop everything here. Here's my O2. So, I just broke some bonds. And now we have 1 of these O2s and 4 atoms of hydrogen. Well, 2 of those can go onto here. Now I have 1 molecule of H2O. Here, I have another, okay. There's my second molecule of H2O. And now, with the remaining O2, because we started off with 2 O2s, and that remaining carbon, let's see if this works. Well, I could add this one to that, this one to that one, and sure enough, now I have CO2. And it turns out that we balanced it right, because all I needed was 1 molecule of methane, 2 molecules of O2, and I got 1 molecule of CO2, and 2 molecules of H2O. And so keep this in mind whenever you see something like this. Whenever you see a formula like CO2, that stands for this. And you can't just throw another carbon on there or another oxygen, because then you wouldn't have the same thing. And I'm really stressing this a lot because I've seen so many people really struggle with that. And when you go to balance a chemical equation, it's really tempting to just say, oh, well, I need another hydrogen over here, so I'll just do this. You can't do that. You have to mess with the coefficients only, because if you get the right number, then you will end up with the right number of products.